So students, in the last video we were discussing about some mathematical tools of physics where we studied logarithm and binomial theorem. In this video we will cover another topic, that is calculus. In calculus we have to study differentiation and integration. Differentiation is actually a mathematical operation in which we divide a mathematical function into several infinitely small components. So it is basically a process of division of a single function into several infinitely small components. As we know that in mathematics each and every operation is represented by a sign, like addition is represented by this, subtraction is represented by this, and multiplication is represented by this. Similarly, differentiation is also a mathematical operation. That's why it must be represented by a sign, that is d over dx. Somewhere if it is written, that means we have to differentiate. This operation is meaningless until a mathematical function is given. If somewhere it is written that y is equals to fx, which means y is a function of x is independent variable and y is dependent variable, then to differentiate we have to take dy by dx. This term fx may have some algebraic terms, some trigonometric terms, some logarithmic terms, or some exponential terms. So we have to differentiate that function with respect to x. So how to differentiate any function? Like if we have x to the power 6, sin x, cos x, log x. So all are the functions of x here. So if you want to differentiate all those functions which are the functions of x, then you have to go through the process dy by dx. So there are some basic formulas to differentiate. Also you should know that if function has a parameter x, then you will differentiate with respect to x. If your function has parameter t, then you will differentiate with respect to t. If your function has parameter z, then you will differentiate with respect to z. So differentiation is always done with respect to the parameter of the function. Let's consider that we have a function y is equals to x to the power n type. Evaluate the differentiation of this function dy by dx. We have a formula. Y is given x to the power n. So we can write here d over dx x to the power n. And finally the formula comes nx to the power n minus 1. It's the first formula, first basic formula of the differentiation. You have to learn this. Okay. If it is given that y is equals to log x, y is equals to log x, then differentiation dy by dx may be written as d by dx of log x, because it is given that y is equals to log x. So you will put the value of y here, and then the formula is 1 upon x. So differentiation of x to the power n is nx minus nx to the power n minus 1. Differentiation of log x is by x. Third is, if y is equals to sin x, then dy by dx will be, means dy by dx of sin x will be cos x. Similarly, d by dx of cos x is minus sin x. You have to learn all these formulas. And d by dx of tan x is sec square x. So in general you can say that a differentiation of all these functions, x to the power n has differentiation n x to the power n minus 1. Log x has differentiation 1 by x. Sin x, cos x. Cos x minus sin x. Tan x, sec square x. E to the power x, it's a new function called exponential function. e to the power x has differentiation e to the power x, and any constant like 3, 4, 5, any number, any number will have differentiation 0. So first property is product rule. So let's consider we have a function y is equals to log x into x to the power n. So you can see here we have a complex function. How to differentiate product of two functions? This you can consider, this term you can consider like function 1, and this term you can consider like function 2. Function 1 and function 2. Or according to the product rule, the differentiation of y with respect to x, because both are the functions of x, differentiation of y with respect to x will be like this: first function into differentiation of second plus second function into differentiation of first. So this is the basic product rule. Property number 2: if we have a function y is equals to cf x, y is equals to cf x, c is a constant, like somewhere it is given that y is equals to 5x. So how to differentiate this? We have to separate the c. So if you want to differentiate dy by dx, we have to separate the c first. The differentiation is done of the function fx. So first we'll see some examples of differentiation. Let's consider that we have a function y is equals to 3x to the power 4, and we want to differentiate it. Then we will write dy by dx. So y is given 3x to the power 5. So we know that in case of differentiation we have to take the constant out. Then this becomes dy by dx of x to the power 5, and differentiation of x to the power 5 is x to the power n x to the power n minus 1. So answer is 3 5s are 15 x to the power 4. Let's see another example where it is given that y is equals to x square log x. It is a multiplication. So we will consider this term as like first function and this like second function. So differentiation of this term dy by dx is given by d by dx. The value of y is given like x square log x. So first into second differentiation plus second into first differentiation. So first into differentiation of second plus second into differentiation of first. So it's a basic rule which is called product rule. So answer comes x square log x has differentiation 1 by x plus log x square x to the power n x to the power n minus 1, 2 minus 1. So at last the answer becomes x plus 2 log x into x. Students, this is your homework. Here we have 4 questions and you have to find dy by dx, or you can say differentiation. So students, complete this work in your fair notebook. In next video we will discuss some numericals of integration and we'll see combination of errors. Thank you.